Hey everybody, my name's Tim Ryder. I am a Principal Solutions Architect at Qumulo, and I wanted to walk you through a demo that we've created that highlights our cloud data platform. It highlights Qumulo's ability to express data as a global namespace and express your storage that may live on premises into a cloud provider or at an edge location where you need to access that data efficiently and with 100% consistency. And so to start, I want to really walk us through the environment for this demo. And we are leveraging Amazon Web Services here, but this would just as easily be any cloud provider. And CDF, even though it's a cloud data fabric, it works across on-prem and from edge to hubs, or from edge to data center and to cloud, and it seamlessly connects those together. But I wanted to walk you through this application that it really does highlight our unique data management capabilities across hybrid environments. And the first thing I want to note is, Qumulo is a multi-protocol scale-out file system, and so we support SMB, NFS, S3, REST, FTP. It's all of those protocols all at the same time. And so any data can be accessed via any protocol within the whole namespace. In this example, we're actually leveraging NFS protocol on premises to write data and read data from an on-prem Qumulo cluster. Could have just as easily been SMB or FTP. However, data comes into your organization, we support that. And then on the right, we're showing an AWS with our cloud native Qumulo cluster running in the AWS cloud. And here our processes are interacting with the data that is written via NFS with the S3 protocol. And this is critical because in the cloud, most cloud native applications and even first party services that do AI ML type workloads typically prefer S3 protocol for data access. And so this dual protocol or multi-protocol capability means that your developers and applications don't need to change the way their preferred access methods. You just use the one that is most applicable to where you're accessing that data. And underpinning the data movement and management is our cloud data fabric technology. And what that is it is a data expression utility that takes data that lives in a hub, which are denoted by these green squares, and it expresses it to another cluster as a spoke. And the spokes are essentially ephemeral caches that are sparsely populated, and we populate it on read in a very WAN efficient method. One of the nice things about this is that you can expose your data to cloud resources, and until you actually read or need that data, we don't move the data there. So you can get rid of multiple copies, replication jobs, things like that. And we don't persist everything at the spoke. All the data is persisted at the hub. Now, it is a cache, and so when data is read here, we keep it there until it's either invalidated or is falls off the cache amount. But you're able to cost optimize this and reduce cloud storage costs to really what you need. And the cache can be managed in such a way that we keep a very small amount that represents only the active data set. And so as you can imagine, in inferencing jobs like this might be, we really don't look backwards. We just kind of want to read it once as it comes in and maybe go back a little bit, but for the most part, we're reading results. And so this gives you the capability to only store what you need in the cloud. And if you think about it in the opposite direction, if the data is persisted in the cloud and you are reading it on-prem, you don't want to move all of that data out if you're not actually going to read all of that. So very efficient way to move data. And the other thing to mention here is that it is 100% consistent. Our intelligent caching and logging and locking mechanisms ensure that you are always reading the most current data anywhere in the topology. It is always 100% consistent. And so the minute that the instant data is written to the source, it is available on the destination spoke side. And you know, it isn't just storage, it's intelligent data movement and management. And Qumulo acts as that data fabric that can bridge on-premises, cloud, and edge in a way where you can store the data where it makes sense to store it and access it anywhere. And then just a little bit about the workflow here. The way it works is we have a process that is on-prem that is writing, in this case, checks. So these check images are being written to a hub directory on an on-prem cluster that is being expressed to an AWS cluster as a spoke. And it is instantly, the minute it is written here, it is picked up from the extraction utility that runs in an EC2 instance via the S3 protocol. And it is sent to Amazon Textract, which is a character recognition software, but essentially this is representing our AI/ML tool through the AWS API. It is some data from the check is extracted, amount, date, check number, routing number, etc., and it is sent back as a JSON file to the check extraction utility, which writes the results to a result hub that lives on the Qumulo cluster via S3, and then those results are a spoke on-prem, and we have a dashboard application that can read those JSON files and visually show us what's going on. And we track some things like how long it takes to do all of this to kind of show the very quick time to results that you can get through CDF underpinning a workflow like this. And so, you could just as easily have left the results in AWS and dashboard them there if you'd like, but we're trying to show a full round trip here of the data. And so that's what we're going to look at. And okay, so let's see this in action with our dashboard here. Here we can see checks are being processed in real time using Textract. We're extracting some data from the checks, the check number, the account number, how much it was, and the check time represents the time that check was written to the on-premises source directory. The download time is how long it took from the time when that file was written to when we actually were able to get it with the S3 protocol in AWS. And then the processing time represents how long it took to send that file to Textract, get the result JSON, and write it to the destination directory. And that gives us a total time between when the check was actually saved, when this image was saved to the on-prem location, and how long it took us to get the data out of it and report it all the way back, go through that whole loop that we talked about. And so when you see this average latency, this is not storage latency. This is latency between when the file was written and when we got results. So on average, it's about 1.5 seconds behind real time that using CDF as the underpinning of this, we are able to get results from things that are happening on-prem and running it through some kind of a cloud AI ML process. You are able to actually interact with this and click a button, and you're able to see the check that was referenced. So this is reading the source data from on-prem. And as you can see, the simulated check has got some dollars and it's been signed, right? And if you notice on here, we have this idea of an anomaly. And so just to kind of illustrate how you can leverage some of these AI ML tools in your environment, we have the ability to inject an anomaly. And so when I hit this button, it's actually going to generate a check. The next one we write to storage will have no signature. And so, once that is done, we can kind of sit here and watch. And as this dashboard refreshes, you're going to see that we actually have a fail. And if I open that check, there's no signature. And so essentially you saw when I hit the button and when I actually saw on my dashboard a light went off, that we were able to very quickly understand and identify an anomaly in that check. And that there could be something much more complex than is it signed, but this is just an illustrative example. And so, we almost instantly see the error, we get notified. The data has been inferenced on-prem or in AWS, but we are writing and saving this data and persisting it in our on-premises cluster. Before we wrap up, I just want to kind of illustrate the three critical Qumulo advantages that were illustrated here. First of all is protocol flexibility. It's the same data accessible via any of our supported protocols: NFS, SMB, S3, REST, FTP, and applications use what they need to access the data. We have intelligent caching that is 100% consistent. CDF ensures only your active data is consuming cloud resources or resources on-prem or at the edge, but you still maintain that full accessibility. And then you have the true hybrid performance, where we've got a sub 3-second processing from on-premises data through a cloud AI service and back. And so really, highlighting the fact that Qumulo isn't just storage, it's the data management and movement platform that makes modern hybrid AI ML workloads possible. Thank you for your time, and please reach out to any Qumulo representative if you have any additional questions.